Okay. Secant and cosecant, which is officially lesson 4.5 in your book. As I said, if you are comfortable and know the basics about sine and cosine, it's not going to be hard to add on some basics about secant and cosecant. Okay? So we will start with just a basic secant and cosecant and sketch those graphs, and then go from, and then we'll, of course, add in changing the period, the phase shifts, and all of that. Okay? So, right at the very beginning. Key to note. Zeros. What do I mean by the word zeros? X-intercepts, where we cross the x-axis, okay? So, where we cross the x-axis, zeros on the graph of sine or cosine become asymptotes on the secant and cosecant graphs. The humps then flip outward to make parabolas between the asymptotes. So our mountain and valleys will flip upside down and turn into a parabola that either is going up or down, depending on whether it was a mountain or valley that flipped, and it's going to be between a set of asymptotes. Those asymptotes are determined by the zeros. Now, probably sounds confusing and a little intimidating right now, but I promise it's not. Okay. Secant. What do you know about secant? Okay. It is the reciprocal of cosine. So notice what it says for secant. Start with the graph of y equals cosine x. So the first thing we'll always be doing when we do a secant or cosecant, so for secant, is we will, you know how I do those dotted line versions before we do a shift? We'll do a dotted line version, except, so that will be to help us place our secant and cosecant graphs. So we'll always start by graphing a dotted line version of cosine x. We'll draw the asymptotes. The asymptotes will be where the zeros currently are. And then we'll draw the parabolas. Okay? So, this is just secant. So we need to start by drawing cosine. What do you know about cosine? Has a period of 2 pi, just basic cosine, right? Has a period of 2 pi. So I'm going to label most of my line up to 2 pi. Get your appropriate 4 spaces. So the middle of 0 to 2 pi is 1 pi. The middle of 0 to pi is pi over 2. The middle of pi and 2 pi is 3 pi over 2. Now, a traditional cosine graph has an amplitude of what? Goes up and down how high? 1. Now, word of warning, don't use that full y-axis to go up and down 1, or you're going to run out of room for your parabolas. Okay? So I'm going to put my 1 more about halfway up and down that y-axis. Same thing about my negative 1. I might have gone a little too low with my negative 1. Okay? Because you need room for your parabolas. Okay. Let's sketch in, so like this is like dotted line type thing, a cosine graph. Where does cosine start? At the top, right? It starts with a max. And then what? It crosses through, which is a 0. And then there's a minimum under pi. Then what? Crosses through 3 pi over 2. And finally, a max above 2 pi. Now, what level are these mins and maxes at? They are across from 1 and across from negative 1. That needs to be fairly accurate. Okay? I know it's easy to overlook that minor detail. So, now, for the benefit of this particular graph, I'm going to go a teensy bit farther left and right. Okay, I mean right here is one cycle, correct? So if right here is one cycle, then I'm just going to go marking each way. So another pi over 2 left is negative pi over 2, right? And what would the graph do at negative pi over 2? It would be a 0. It would cross again, yes? And then if I go past 2 pi, what's the halfway marking past 2 pi? Yeah, it's 2.5, if you will. And 2.5 is 5 halves. And that's going to be another 0. Okay, so we have a sketched cosine curve in. Are we okay with what I've done?
Yes.
Okay, so any zeros become asymptotes. How do I draw an asymptote? Dotted vertical line, right? Technically, it's an invisible line, but we draw it in so we can see it. Kind of like technically, this cosine graph isn't really here technically, but I need it for a visual. Okay, so now that means we're going to have a vertical asymptote at pi over 2, a vertical asymptote at 3 pi over 2, and I added on these other two on purpose. We're going to have a vertical asymptote at 5 pi over 2 and negative pi over 2. Everywhere we cross the x-axis. So everywhere there's a 0, we're going to have an asymptote. I went ahead and yes, because I want you guys to see the full graph.
And we just extended that for like what we're about to do.
Yes. Okay, so now it said to draw the parabolas going outwards. So what we're going to do, for instance, between negative pi over 2 and pi over 2, I have a mountain. We're going to flip and draw a parabola that is a right side up parabola that touches our mountain right at the top. So the top of your mountain and the bottom of your valley are going to touch. They're going to be like tangent to each other, meaning they're going to touch each other. And my my parabola is going upwards, running along inside the asymptotes, never touching, never crossing the asymptotes. Important is that the bottom of your parabola is at the top of your amplitude. Does that make sense?
So that's the same thing for the valleys.
So now we have a valley from pi over 2 to 3 pi over 2. We have a minimum at pi. So underneath pi at negative 1 is going to be the top of a parabola. My parabola has that max there. It goes down alongside the asymptotes, never crossing, never touching.
What if we like drew a dot where those like connect with each other just so we don't
Yeah.
get a more spectrum?
And then between 3 pi and 3 halves and 5 halves, we have a mountain. Flip it upside down and it becomes a valley. There at 2 pi is where the minimum of your parabola is. Now, officially, we have a little bit over a period. If you want to get official, remember a period is 0 to 2 pi. So your minimum requirement here for a secant graph, because it's based on cosine, would be 1 full parabola in the middle and 2 half parabolas on the outside, which is the equivalent of 2 parabolas, yes? But do you see what I have blocked off there? That's your minimum requirement. Now, is it easier to maybe just draw 3 parabolas on this one? It's up to you. But that's your minimum requirement that I would need, is 1 and 2 half parabolas. Or go for 3 if you want. Make sense? Okay. Sorry, I needed to open a test on Schoology for someone. Ready to try cosecant? Cosecant is based on sine x. So if this is based on sine x, we're doing the same type thing we just did, except sine is going to be our base graph. Starting where? Where's the sine graph start? Sine starts at the origin, right? As 0, 0. Okay. Sorry. So let's go ahead and label the same stuff. Which means, what is a cycle? 2 pi. In the middle of 0 to 2 pi is pi. The middles of my pi's, pi over 2, 3 pi over 2. Okay. What's my normal amplitude? 1. So again, do you now see why I say don't use your whole vertical axis for your amplitude? It is so easy. I am so guilty of making it too big, and then it makes it hard. You know, your secants and cosecants run together with the next graph, which is probably what's going to happen here. Okay. Now, what am I sketching right now? A sine graph. Okay, a sine graph starts at the origin and does what? Mountain first. So max it over pi over 2. A 0 at pi. A minimum at 3 pi over 2. A 0 at 2 pi. Again, remember this is dotted, because we're not actually drawing a sine graph. We're drawing a cosecant graph. So officially this is just dotted. This is just to place our parabolas. Now, I still need to see it though, right? It can't be totally invisible. Just before anyone tries to get smart alecky and try it with me. Okay, what do I do now? Asymptotes. Where are my asymptotes this time? 0, 1 pi, 2 pi, if we kept going, 3 pi, 4 pi, 5 pi, 6 pi. Anytime there is a 0. So anytime my sine graph crosses the x-axis. No, I don't need to go extra this time. You'll see why. Okay. We got our asymptotes. Now, in between the first asymptote, 0 to pi, currently a mountain. Flip it upside down. I have a right side up parabola. The bottom of that parabola is at the point pi over 2, 1. And then, in between 1 pi and 2 pi, we have a valley. Flips to make an upside down parabola. And that upside down parabola touches the minimum on the sine graph. Now, minimum expectation for a cosecant graph is 2 full parabolas, which is equivalent to what it was last time, right? Last time it was 1 and 2 half parabolas. This time, Levi was questioning, you're not going extra. Do you see why I didn't go extra? Yeah. My asymptotes are right there at the end. I get 2 nice, neat parabolas. That is minimum requirement. That is 1 cycle. Okay? It is. It's sine and cosine. You just add the step of the asymptotes and parabolas. Which is why I said, good news, bad news. If you are comfortable with sine, cosine, this isn't much more of a challenge. If you're, if sine, cosine is a struggle, well, can you see the writing on the wall? This is going to be a little bit of a struggle till you get sine, Now, this will also help you improve your sine, cosine skills, right? Because we have to graph that sine, cosine before we can do anything else. So, here's what I'm going to ask you to do. We have about 3 minutes left of class. Before you're allowed to close up shop for the day. On example 1, write down the information I would normally write down at the left. And that's what we'll start with on Monday. Does that make sense? So center line, amplitude, reflection, period, shift, and identifier, we're going to be graphing a sine or cosine curve. Write that kind of information down, and then we'll start by going over that on Monday and graphing it. Sound good?